So this is exercise 212A, and in A, they want us to solve for x. We're told alpha times x plus beta is equal to 1 over alpha x minus beta. So as I see it, what I'm seeing here is I have one quantity equals 1 over another quantity. So, if I call this one quantity A and that B, I just want to multiply both sides by B, so I'll get A times B equals 1. And so when I do that, I'll have my alpha x plus beta times alpha x minus beta equals 1. And now, as I look at this, I could write out the whole thing, but what I noticed is, again, I have something like an A plus B times an A minus B. And what I know is if I take a form like that and multiply it together, I get A squared minus B squared. Okay, so when I multiply this side together, I'll get an alpha x quantity squared minus a beta squared equals 1. So I have that. Now I'll go ahead and distribute that exponent. So I have alpha squared x squared minus beta squared equals 1. Now I'll add beta squared to both sides. So I have alpha squared x squared equals 1 plus beta, or beta plus 1. I think I'll write it as 1 plus, or beta squared, that is. And now divide both sides by alpha squared. So I have x squared is equal to 1 plus beta squared over alpha squared. And so at this point then, take the square root of both sides. Now, in this case, though, I want both the positive and negative square root. So I have that x is equal to both the positive and negative square root of 1 plus beta squared over alpha squared. Now, this is one of these things that I would probably just leave it like this. However, if you were to take it a little further and you had plus or minus the square root of 1 plus beta squared over the square root of alpha squared, now it kind of gets into a funny area here, because if I do this, if I simplify that, technically I should simplify it to the absolute value of alpha. Okay, because if alpha were a negative number and I squared it, suppose alpha were negative 2 and I square it, I get 4. And then when I take the square root, I get positive 2, not negative 2. So, so this really is an absolute value of alpha. But the funny thing is, so I could write it like that. I could say this is plus or minus the square root of 1 plus beta squared, then over the absolute value of alpha. But it turns out if alpha is negative or positive, this plus or minus idea still works. And so I could write this as plus or minus the square root of 1 plus beta squared over alpha and get away with it. Okay. Now, the funny thing is, if alpha is negative, technically I should, instead of writing plus or minus at this stage, I should write minus or plus, because what was plus turned to minus and so forth. But, we can get away with it. But like I say, this is a perfectly good answer right there. And so I'd probably just stop right there, and there would be my work. And so that's 2.12a.